So let's see. Okay. So this Friday we will have homework 7. So it covers 3.1, 3.2, 1.8, and 3.4. And then we also have quiz 4. So for those of you coming late, I just checked your classmates' exam formula sheet 1 and 2. So make sure you fill those out. The answer is on the website at the very bottom. You see? Use the formula sheet for exam 1 and exam 2. And these are the answers. So if you lose that copy, you can print it out, the blank one, and then fill it out. Okay, make sure you can memorize all those formula. And then, yep. So homework and quiz this Friday. Our review session is on Wednesday from 8 p.m. to 10 p.m. So join our tech live, okay? But now you can start working on your practice exams. So you have, 1 week to, today is what? Here, yes. 29, okay, so you have 1 week to study the practice exams. Okay, if you have questions, ask me. Okay. So, yes. So 4.1 is not on exam 2. It's going to be on exam 3. Okay, but when you are reviewing the exam 2 materials, we still need to cover the new stuff. Okay. All right. So section 4.1 and 4.2, rational functions. A rational function is a polynomial over a polynomial. So you have p of x over q of x. They are both polynomial. Okay? And here are the following, we have some pictures. The first picture, we have x over x minus 2. Do you remember that when we find the domain, there's 2 things we check, right? First thing, if you see square root of a, we need the a to be what? Greater or equal to 0. And then when we see fractions, what do we need? A cannot be 0. Therefore, if you look at, this function, x over x minus 2, we need the denominator is not 0, right? That's the domain. Therefore, x cannot equal to 2. So, which means we have a vertical asymptote here. So this is a vertical line, okay? The function is not defined at that point, x equals to 2, right? And then you can see our function is approaching to this line, but it's never touched the line. So this is what a rational function looks like. You have some, this is called vertical asymptote. This is when the denominator is not 0. And then how about look at the second picture? So this is the function. Right? The domain will be the denominator. It's not 0. Well, this is a quadratic function. Right, everybody? Degree 2. So quadratic function. Can we factor it? Let's see. X, and this is 1. We're not able to get the factors to have x in the middle. So there's something called discriminant, right? If you can remember, this is b squared minus 4ac. In this case, b is what? 1. A is 1. C is also 1, right? 1 minus 4 is negative 3. Oh, do you see is the discriminant is negative? What does that mean? Okay, we call that, if discriminant is positive, that means we have 2 real roots. Okay, so the parabola intersects the x-axis with 2 points, right? We have 2 x-intercepts. And if the discriminant is 0, then we have 1 real root. So the parabola touch the x-axis. If the discriminant is negative, the parabola lies above the x-axis. So we have no real root. But in this case, we will have two complex roots. Do you remember these? Right? When we talk about quadratic function? Yes. So therefore, this discriminant is negative. Oh, well, in this case, our quadratic function is always positive. Right? It's always positive. So we don't have any real roots. Therefore, the denominator is always positive. It won't be zero. So the domain is all real numbers. Okay? You don't have any vertical axis there. Right? Everybody? So yes. Therefore here the domain is all real number. Okay? And then the previous one, the domain is when x is not equal to 2. Okay, now look at the third picture. Right? We have fractions. We also set the denominator not equal to 0. Right, exactly. We don't worry about the top. So keep in mind, if you see square root, you need the things inside the square root to be greater or equal to 0. When you see fraction, you only need the denominator not equal to 0. Do you care about the numerator? No. Okay? So this is when you find the domain. You don't care about the numerator. But when you graph the function, sometimes the numerator matters. Okay? Alright, so the denominator not equal to 0. Aha, this one we are able to factor. So x squared, yeah, x squared we can factor as x and x. Minus 6, what are the factors of minus 6? 2, 3, and 6, 1. In this case, because it's negative, so negative 6, positive 1 will give you negative 5x. Right? So therefore we get negative 6 and positive 1. If this is positive 6, then you will have negative 2 and negative 3. Is that okay, everybody? If this is positive 6, you have negative 2 and negative 3. But because this is negative 6, so negative 6 and positive 1. Okay, everybody? So it's not equal to 0. Okay, attendance. So also, yes, I want to meet you weekly. So please put the time and yes. And exam is next week. So I really hope that I can meet you this week and next week. I want to really push you. I want you to do well on this exam. Okay, so try your best. Make sure you understand every problem in class. Review your notes and like hide the solution and try if you can redo the problems. Okay, so do the practice exam early. Do it multiple times. And for the problem that you lose points, so you can grade your work with the solution. For the problems you lose many points, change the number and do more exercise. Okay? So math is really you do a lot of exercise, your muscle can get used to it, right? All right, and so therefore we have x minus 6 not equal to 0, and x plus 1 not equal to 0, x not equal to 6, and x not equal to minus 1. Therefore, you see 6, we have the vertical line, and minus 1 is here. We also have a vertical line there. The function is not defined at those two lines, right? Do you see? Yes. That is the domain. X not equal to those two numbers. Okay. Now we keep going. Most of the time, rational functions have vertical asymptotes and a horizontal asymptote. An asymptote is basically a line or curve to which the graph of the function gets closer and closer. So like this line, do you see the function is get closer to it? Yeah, and this part is get closer to it. And also these two lines, the functions get closer to They never touch. Just get closer to it. Okay? So there's the asymptotes. So virtually, there are 4 ways a function may behave near vertical asymptotes. Okay, so we have 4 of them. The first one, you can think of, okay, this is the asymptote. We have 4 directions. 1, 2, 3, 4. Right? This is the left and it's top, right? So left means, well, this is A, right? Left means X is approaching A from the left. Do you agree, everybody? So when you're approaching it from the left, the notation is X goes to A from the left. You know left side is negative, right? So A negative means X is less than A. So X goes to A from the left. Is that okay, everybody? That is what is A to the negative means. X approaching A from the left. And then, do you see the Y goes to infinity? You know, top is infinity, the bottom is minus infinity. Yes. So that's why the notation is X goes to A from the left, Y goes to infinity. And then, oh, this one, left or right? Left or right? Left, top or bottom? Bottom. Left means X goes to A from the negative side, and Y goes to minus infinity. The bottom is minus infinity. The top is infinity. Okay? And here, left or right? Right. So see, X goes to A from the positive side, from the right. Okay, the positive means from the right. So means X is bigger than A. So it is approaching A from the right. And then this is the top. Top means Y goes to infinity. Okay, everybody? And the last one, left or right? Right. Top or bottom? Bottom. See? As X goes to A, thank you, from the right, Y goes to minus infinity. So it's one of those 4 types. So you decide whether it's left or right or top or bottom. Okay, everybody? All right. So, and we say the vertical asymptote is the line X equals A. Don't just say A. A line is an equation. Equation. X equals A. Okay, everybody? All right. Okay, so for rational function, vertical asymptote happens when where the denominator is 0. Okay. So I want to give you some notation. 1 over infinity is 0. Now why is that? Think about it. 1 over 1,000 is 0.001. Right? 1 over a big number is going to be very, very small. So 1 over infinity is 0. Is that okay, everybody? And 1 over minus infinity is also 0. Right? If you have a minus 1,000, this is negative 0.001, but it's still close to 0. Right, everybody? 1 minus negative 1,000 is negative 0.001. And this number is close to 0. So 1 over some number getting close to infinity, this will go to 0. And 1 over 0 is undefined. Yeah, we know that 1 over 0 is undefined, but 1 over 0 plus is going to be infinity. So 1 over 0 plus, what's that mean? Okay, 1 over a number that is positive and very small. Think about it, 0.001. You get 1,000, right? 1 over a positive number, which is close to 0, you get a big number. So 1 over 0 plus is infinity. How about 1 over 0 minus? Any guess? Negative infinity. Yes. Please keep these in mind. Okay, everybody? All right. Okay. So because we are a little bit behind schedule and we want to go over the examples slower, so we might not able to cover all the examples on your worksheets. But on the course website, I have solution to all the problems. So I would say part A, do it at home. Okay. So part B, we want to find the vertical asymptotes. And then we also want to determine what happened to the y as x approaches from the left and from the right to the vertical asymptotes. Okay, so this is how we would do it. First step, factor. Okay? Factor is really a key word. Okay? So when you see something like this, factor the numerator and the denominator completely. Okay, how do we factor the numerator? You look at 3x squared. So 3x squared, what are the factors of 3x squared? 1 and 3, right? So x and 3x. Yes, everybody? Okay. How about I ask you questions, you take turns to answer my questions. Hi, Derika. What are the factors of minus 1? 1 and minus 1, right? Okay, if we put 1 here and we put minus 1 here, what happened? We get, multiply the outside, we get negative x. Multiply the inside, we get 3x. 3x minus x is 2x. But we have negative 2x, which is not right. So that means we need to change the sign, right? So we change the sign. Then this is negative and this is positive. Now do you see? We multiply the outside, we get what?
Is there any more of these left?
Oh.
Yeah, that's what I was confused. I thought you already gave it out.
Oh, here. Yeah, this is the new handout today. Right. So we multiply the outside, we get x. We multiply the inside, we get negative 3x, right? Now negative 3x plus x is negative 2x. Questions?
You always put the sign.
Because it didn't work. It missed a sign. So remember what we did? We put plus 1 and minus 1 here. Then we get minus x and positive 3x. We add them up together, we get 2x. We don't get minus 2x. We are off by a sign. If you are exactly off by a sign, that means you flip the sign, and that it will make it work. Yes. So there are a lot of combinations. You need to keep trying until you find one. Okay. So that is the numerator. Denominator, Quinton. What are the factors of 2x squared? Yes. What are the factors of negative 2? Negative 2 and 1. So we don't know which one worked, okay? So we just put negative 2 and 1 and see if that works. If it does not work, then we switch the numbers, right? So we multiply the outside. What's x times 1? 1x, right? Negative 2 times 2x? Negative 4x. Negative 4x plus x is negative 3x. Now you check with the middle term. Negative 3x, but we get 3x. It's off by a sign. Then what do we do? Yeah, flip them. Okay, so therefore this is plus and this is minus. Now check again. Multiply the outside, we get what? negative 1x. Multiply the inside, we get positive 4x. Now when we add them, we get positive 3x, right? Yes. So this is the factoring. Okay, everybody? So if you use other method, feel free. But if you didn't make a mistake, no matter what method you use, you should have the same answer. Okay, everybody? Mm-hmm. So, yes, the first step we factor. Okay. And then questions.
If you don't split the signs, you come out with the wrong answer.
Yes.
Yeah.
You give the wrong answer, then everything after is all wrong. Yeah, yes. So this is the first step. Very, very important. Okay. And now second step, we find the domain. You see here, the domain is when the denominator not equal to 0. Right? Domain is when the denominator not equal to 0. So, Diana, a product of two factors is not equal to 0. What do? You set them not equal to 0, right? Okay, x not equal to what? Negative 2. And this one, x not equal to 1/2. Very good. Okay. So this is the domain. So far, so good, everybody? Mm-hmm. All right. Now, what do we do? Third step. Okay. So we might have vertical asymptote at those x values. Okay, we might have. But in order to check whether these are exactly the vertical asymptotes, you have to let x approaches to those numbers and see if your y goes to infinity or minus infinity. Okay, everybody? So let's look at this number first. So let me use a different color. Okay, this is so important. So let x goes to minus 2 from the left. Okay, x goes to minus 2 from the left. Then what happened to x plus 2? It goes to 0 from the left or right? Yeah, from the right. Okay, why is that? So we look at the first number, negative 2, right? And then you want to see what happens when x approaches negative 2 from the right. And you also want to see what happens when x goes to negative 2 from the left. So let's look at the right first. Yes. We will do from the right and from the left, and then this number from the right and then from the left. We'll do 4 of them. Yes. Okay. So, but x goes to negative 2. This actually means x is bigger than negative 2, right? Yes. X approaches negative 2 from the right. So x is bigger than negative 2. So when you add 2 on both sides, you get x plus 2 is bigger than 0. That is why x goes to minus 2 from the right, then x plus 2 will go to 0 from the right. Is that okay, everybody?
Where are you getting your numbers from? Like your x minus 2, your x plus 2?
From the domain. So the first step, you factor. Second step, you look at the domain. Because, look at this picture. How do you find those vertical asymptotes? You usually set your denominator not equal to 0. And those values, it's very possible that you might have a vertical asymptote there. But to verify this is in fact a vertical asymptote, you have to check when x approaches from the left or from the right, whether your y goes to infinity or minus infinity. Okay? Because it could happen that like, okay, like this function, like maybe x plus 3 over 2 x plus 3 times x minus 1, something like this. Then you see this cancel, you get 1 over 2 x minus 1. But when we talk about the domain, right, when we talk about the domain, you also need to set the x plus 3 not equal to 0. But you will see this x not equal to -3, the -3 here is not a vertical asymptote. It's just a hole, just a missing point. You don't have the function go to infinity or go to minus infinity there. Okay? So that's why the first step you factor it. The second step, you set your denominator not equal to 0. You get some x values. You might have vertical asymptote at those x values. Okay, but you're not, because it's not always vertical asymptote. You have to check. You have to let x goes to that number from the right and from the left to see if your y goes to infinity or minus infinity. Yeah. Okay, very good. So yes, that's why we let x go to -2 from the right. Then x plus 2 will go to 0 from the right. Is that okay, everybody? Yes. Plus sign means it's approaching it from the right. Minus sign means it's approaching it from the left. Yeah, right, everybody? Okay, so now keep going. Y goes to. Okay, so now we plug in the factored form. This is so important. Make sure you plug in the factor form. So you're plugging in x is -2. So look at this factor. You plug in x is -2, right? You will have -2 minus 1, right? Next factor. 3 times -2 plus 1. Yes, everybody? And then next one. Do you see when you plug in x is -2 plus 2 is 0. But you don't just write down the 0. You write down 0 plus. This is so important. You don't want to write a 0 because 1 over 0 is not defined. Okay? X is not equal to -2. X is approaching to -2 from the right. So 0, 0 plus, or 0 minus, it make a big difference. Okay? All right. So,
Why put 0 plus in the denominator again?
oh, because x minus 2 is going to 0 plus.
Oh, okay.
Yeah, x minus 2 going to 0 plus. So you don't put 0, you put 0 plus. Okay, everybody? And then here, 2 times x. So x is now -2 minus 1. So far, so good. Okay. Haley, what is -2 minus 1? -3. And 3 times -2 is -6 plus 1. -5. And 0 plus, it came out. 2 times -2 is -4 minus 1. -5. Okay. If you have constants, you see the numerator is constant, right? Over 0 plus, the answer will be either positive infinity or minus infinity. The positive or minus, you look at how many negative signs. How many negative signs? 3. So it will be positive or negative? Negative infinity. Okay. You have questions? Oh, because you plug in x as -2. So you plug in x as -2 into this factor form. X is -2, then you have -2 minus 1. X is -2, so 3 times -2 plus 1. X is -2, you have 0, but you don't want to put 0. 0 will cause a problem. You will have undefined, right? It's actually 0 plus. Okay? But the other factors, just plug in. Yes. The other factors, just plug in. And this is the problem factor. You replace it with 0 plus. Okay? So, okay. This process might be new to you. So try to understand the process and do it. Okay? Yeah, this is new to you. So we're trying to understand this process. What are we doing? You want to think about when x goes to -2. Where's -2? Right here. When x approaching to -2, you want to what? You want to figure out what's the y, right? So what do? You want to plug in the x that's getting closer, closer, closer to -2. Therefore, you plug in x is -2 for all these factors, but then this is special because this will be 0, right? And you don't want to put 0 because x is not equal to -2. It's approaching to -2. So therefore, x plus 2 is approaching to 0 from the right. It's not exactly 0. And then you have constant over 0 plus. You get infinity or minus infinity. Is infinity or minus infinity? You count the number of negative signs. 1 negative sign, 2 negative sign, 3 negative sign. So 3 negative signs multiplied together, you get negative. So you get negative infinity. Is that okay, everybody? So we would do more examples. So yeah, we do more examples.
So there's a negative on top of 0 plus.
You count how many negatives. If you have an even number of negatives, you multiply them, you get positive. If you have odd number of negatives, multiply them, you get negative. So you have 5 negative numbers multiplied together, you get negative. If you have 7 negative numbers multiplied, you get negative. The 10 negative numbers multiplied together, you get positive. Right, you get even number, positive. Right. So 15, right, is positive, but then here, your -5 is still negative.
Oh, okay, yeah.
Yeah. So when you get to this part, don't need to multiply the numbers. You just count how many negative signs. Yes. Okay. So we get y equals to minus infinity. Now keep going. X goes to -2 from the left. Zach, can you tell me what happened to x plus 2?
0 minus.
Yeah, very good. 0 minus. And then the y goes to, do you see here? When we plug in -2, will this factor change? When we plug in x as -2 from the left, this factor remains the same. And this factor remains the same, right? And then this, instead of 0 plus, we have 0 minus. And this factor will remain the same, right, everybody? So you can actually go to, so make this arrow longer. The top, you still get -3, and you still get -5. But then instead of 0 plus, we have 0 minus. And then we have the -5. Justin, how many negative signs here? 4. So we will get positive infinity. By the way, positive infinity means infinity, so you don't have to write down the positive sign. So far, so good, everybody? So this is the process, Okay, you factor the numerator and denominator. You find the domain, which is you set the denominator not equal to 0. You get some x values. Okay, and then you let x approaching those x values from the right and from the left, and then you look at the y. What happened to the y? So we keep going. X goes to 1/2 from the right. X goes to 1/2 corresponds to which factor? The 2x minus 1, right? So you get 2x minus 1. It goes to what? 0 plus or 0 minus? 0 plus. That's always the case. So you let x go to 1/2, and then that means this factor goes to 0. If you let x go to 1/2 on the right, and then this factor will go to 0 from the right. They always match. Okay? Now, what happened to your y? You look at the factor form. Now you plug in what? 1/2, right? You plug in x is 1/2. Even. The first factor, what do? You get 1/2 minus 1, right? The second factor, 3 times 1/2 is 3/2, right? Plus 1. And then the next factor in the denominator, 1/2 plus 2. Yes. How about 2x minus 1? 1 minus 1 is 0. Do you put 0? 0 plus. Good. Yes. Okay. Now what happened? So this factor here, this factor is positive or negative? This factor is positive or negative? Positive. So you have negative, positive. This one is positive, and 0 plus. You get what? Yeah, negative infinity. Is that okay, everybody? So you don't really need to know what exactly this number is. You don't really care. You just know it's constant over 0 plus or 0 minus. It's gonna be infinity or minus infinity. You really care about the sign. Is it positive or negative? Okay, everybody? Keep going. X goes to 1/2 from the David.
I'm sorry, I was still
Oh,
finding other stuff out.
sure. Yes. So we let x approaches 1/2 from the right. So now we let x approaches 1/2 from the left. Okay. And how would this change? Do you see this part is very similar to this part? So we just change one little thing. So we keep going, and this. What do we write? 2x minus 1 goes to 0 negative. And then the y will go to, what happened? You get still a minus number, still a plus number, still a positive number. But then what happened next? This becomes 0 minus. So the answer is infinity. Yes. Okay. So we actually get, okay, so we get vertical asymptotes are x equals -2 and x equals 1/2. Okay. So if you want to draw the picture, you have -2 here, and you have 1/2 here. We have vertical asymptote here, right? This tells us that when x goes to -2 from the right, then the y goes to -infinity. -infinity is top or bottom? Huh? Top or bottom? The bottom, right? So it's kind of here. Yeah, it's from the right side and it's the bottom, right? And how about this piece? When x goes to -2 from the left, the y goes to infinity, like here, right? And then when x goes to 1/2 from the right, the y goes to -infinity. -infinity is the bottom, right? And then here, when x goes to 1/2 from the left, and the y goes to infinity, infinity is at the top, okay? So therefore, this function look like something like that. Okay, everybody? So we know what happens when x is near those verticals. Any questions about part B? So we have 3 steps. What's step 1? Factor. Step 2, find the domain. You set the denominator not equal to 0. You get some x values. Step 3, let x approaching it from the right and left. Yeah, and see what happens to the y. Will it infinity or -infinity? And you plug in what? The factor form. Don't plug in the original form, because if you plug in the original form, you just get something like over 0. You won't be able to see what happened to the sign change. Okay, everybody? So make sure you plug in the factor form. Let's see. Okay. Let's see. Okay, we don't have much time left, but I do want you to do some exercise. Okay, let's see. Can you do part C? Yes, do part C. 3 steps. For the remaining exercise, the practice, please do it at home and then check the solution on the website. Yes, yes, that's the correct answer. And then you set the domain, the denominator not equal to 0. Good, yes, good. Yes, that makes sense. That number from the right and the left. You see, this is 4. So that's the 4 is 1. Good. So x minus 4 goes to 0. So put an arrow there. And And here, don't put an arrow. Comma. And then you do this. What do? You use the y. What happens to y? And yes. Right. So this is first step and second step. So second step, first step factors. Second step when you say the denominator, right? If you have the denominator not equal to 0, so you get those two numbers. Then step 3, you let x go to the first number on the right side, and what happens with that factor? It goes to 0 plus, and then what happens with y? So you let x go to 4 from the right. Good. Good. You mean 4?
Oh, yeah.
Yeah, 4. And then from the right. And then what happened to your y?
I would do y
Goes to the factor form. You plug in
I would like
x is 4. So that's what you first step, you write it as the factor form. This is not the factor form. Yeah, but the numerator is x. This is only the denominator. So maybe you rewrite it better.
So you say x.
Yeah.
So then what?
4 on top. And then the bottom. See? X minus 4.
Oh, so he's
Yes. 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 Okay, and then minus 4. So x goes to 4. Okay, that corresponds to this factor, right? So then you put x minus 4 goes to 0, and then because it's plus, and then it's plus. And then your y goes to, you put 4 inside this factor. You put x is 4 inside this factor.
Why? Why would I plug in the x?
Yeah, just this first.
Why?
Yes. Okay. This is error. It will be 4, because this is x not equal to 4. It will be 4 plus. And then you do x minus 4 go to 0 plus. X minus 4. And then the y.
Oh,
Yes. Good job.
Oh.
As a math question.
Okay.
Okay. This one. So that's what I'm doing.
Say that about.
0 plus.
0 plus.
Is this a tie? Okay, let's check our answer. Let's check the answer together. Before you leave, okay, just give me 1 minute. So this is session 4.1. Okay. I didn't write it down. Okay. So let me just write it down quickly. Okay. So you have, a lot of you get the factoring x minus 4, x plus 1, right? So your domain x not equal to 4 and x not equal to minus 1, right? So you have x goes to 4 from the right. That corresponds to the factor x minus 4. Go to 0 from the right. And then your y goes to, you plug in x is 4. You see 4, but the x minus 4 will go to 0 plus 4 plus 1 is 5. Then you see positive, positive, positive. The answer is positive infinity. And then when x goes to 4 from the left, x minus 4 goes to 0 minus. What happened to your y? Negative infinity, because you changed the plus to minus, right?
Okay, so we were both right.
And when x goes to minus 1 from the right, x plus 1 goes to 0 from the right. And then your y goes to, so x is minus 1. Minus 1 minus 4 times x plus 1 go to 0 plus. Do you see this is negative and this is negative? Two negative make it positive. So this is positive infinity. And when x goes to minus 1 from the left, x plus 1 goes to 0 minus. And the y goes to, you see, minus 1, and this is minus 5, but this is 0 minus. How many negative signs? 3.
So why would you do a positive side and then a negative side?
Because it's easier to do the positive sign first and then a negative sign. Because later on, if you have some problem like this, if you have like square here,
Yeah.
positive square is still positive, but negative square will change the sign.
How do we know how do we know, would it say that you need to do positive instead of negative?
You do both.
You do both?
You always do both.
Why?
Because you want the problem asks you what happens when x approaching it from both sides.
Oh, both sides. That's what I was asking. Okay.
Yeah. All right. Have a nice day.
So will it ever say just from one side?
It won't. It always.
It'll just say both sides.
Yeah.
All right. Have a good day.
Thank you.
All right.
You too. Oh, thank you.